Forget delivery numbers, forget stock charts. That's the old Tesla story. The real story, the one that actually matters, is hiding in plain sight. And once you see it, you can't unsee it. Imagine this for a second. The future of Tesla isn't a single car. It's not a flashy feature. It's not even a product you can point to. It's a chain reaction, a series of quiet breakthroughs happening right now behind factory walls, away from the headlines. Batteries, manufacturing, AI, energy, each one powerful on its own. Together, they spin a flywheel, faster, cheaper, smarter, reshaping cars, labor, and transportation all at once. And today, you're stepping inside that blueprint. 6 innovations, 5 years, one radical shift in how the world moves. By the end of this, you won't see Tesla as a car company anymore. You'll see an industrial machine being rewired in real time. So settle in, and if you want more deep dives like this, make sure you like and subscribe to Dravexa. Now, let's start at the foundation, because the first pillar is something you'll never actually see: the 4680 battery cell. At first glance, you might think it's just a bigger battery, 46 millimeters wide, 80 millimeters tall, numbers on a spec sheet. But that's not the story. The story is what this battery does to manufacturing itself. Here's what you need to know. Batteries are the single biggest bottleneck in electric vehicles: cost, complexity, time. For years, battery production has been slow, messy, and brutally inefficient. You mix chemicals into a thick slurry, you smear it onto metal foil, then you bake it in massive ovens that burn energy and money just to dry the stuff out. It's expensive, it's slow, and it scales like molasses. Now imagine cutting that entire step out. That's what Tesla set out to do with the 4680's dry electrode process. No slurry, no solvent, no ovens, just dry powder pressed directly into place. Smaller factories, less energy, faster output, lower cost. It sounds simple, but it nearly broke them. The anode, solved. The cathode, a nightmare. The material cracked, the machines failed, scaling it was brutal. For years, the promise stayed just out of reach. But here's the quiet shift you probably missed. After a major technical pivot, reports from late 2025 suggest Tesla finally locked the dry cathode design. Not a concept, not a demo, a finalized solution. Now the challenge isn't if it works, it's how fast they can ramp it. And that matters more than almost anything else Tesla is doing. Because once this clicks, the math changes. At an internal meeting in early 2025, Tesla revealed something wild. The 4680 cells produced in Texas were already cheaper per kilowatt hour than the batteries they buy from suppliers. That's before a fully dry cathode. Push costs lower again, and suddenly the idea of a truly affordable mass-market Tesla stops being a dream and starts being inevitable. Even with Tesla pausing its next-gen low-cost car for now, make no mistake, this battery is the reason that car will exist at all. But it goes deeper. The 4680 isn't just a battery, it's part of the car's skeleton. Instead of stacking cells into a heavy pack, Tesla turns the battery into a structural component. Fewer parts, less weight, more rigidity, more range with the same energy. A stiffer, safer vehicle built like an aircraft wing instead of a suitcase. This is the only reason vehicles like the Tesla Semi or a high-mileage Robo taxi can ever make sense financially. The margins don't work without it. The production ramp has been painful, yes, but pain is temporary. Infrastructure is permanent. And over the next 5 years, this shift quietly unlocks everything that comes after. And we're just getting started. The shape of the battery gets the headlines, But what really decides the future is what's sealed inside that metal can. You might expect the 4680 to be the end of the story. Bigger cell, better structure, done. But Tesla doesn't stop at containers. The real race is chemical, atom by atom, reaction by reaction. Because battery performance, range, lifespan, charge speed, it all lives and dies by chemistry. And right now, Tesla is sprinting. Let's start with the anode. Today's batteries mostly use graphite. Reliable, stable, boring. Silicon, on the other hand, is a monster. It can hold dramatically more lithium. More lithium means more energy. More energy means more range. Simple math, brutal problem. Because silicon swells a lot. Charge it and it expands. Discharge it and it contracts. Again and again. Do that enough times and the structure fractures, performance collapses, and the battery dies young. So the challenge isn't adding silicon, it's controlling it, blending it, coating it, engineering it so it stretches without snapping. This is where Tesla quietly pours years of work into recipes no one outside the lab ever sees. And that's just the near-term fight. The long game, solid-state batteries. This is the final boss of energy storage. No liquid electrolyte sloshing between electrodes, instead a solid material, cleaner, safer, denser. In theory, you get batteries that weigh less, store more, charge faster, and are dramatically harder to catch fire. Some early tests show over 90% capacity after thousands of cycles. That's not incremental, that's transformational. So Tesla's unboxed method throws that entire 100-year-old concept in the trash. Instead of one long, slow line, the factory is organized into parallel processed chunks. Think of it like building a Lego car. You'd never build the frame first and then try to stuff the little driver through the tiny window. It's absurd. You'd build the floor. You'd build the front block, the rear block, the cabin, and then, at the very end, you just click them all together. This is exactly what the unboxed process does. Imagine this. Over in one corner of the factory, that massive front Giga casting is getting its motor, its suspension, its steering. At the exact same time, in another corner, the rear Giga casting is getting its motor. And simultaneously, the central floor pan, which is the 4680 structural battery pack, is being prepped. The real magic? Open access. Workers and robots have a full 360-degree attack. You want to install a dashboard? It's simple. There's no roof, there are no doors in the way. It is massively faster. It's more ergonomic. Then, and only then, do these huge pre-assembled, pre-tested modules meet the front, the rear, the painted side sections. They're all joined to that structural pack in one final step. The results? Tesla claims a staggering 40% reduction in factory footprint, a 25 to 30% increase in production speed, all while slashing the cost to build the factory in the first place. This isn't just an improvement, it's a new paradigm. And if you want to follow this revolution, you need to be subscribed to Dravexa. This is the only way Tesla can realistically build that $25,000 car at high volume and, most importantly, at high margin. But here's the secret. That unboxed method, that whole Lego block strategy, is only possible because of another Tesla innovation, Giga casting. You have to understand, traditionally, a car's underbody is a complex puzzle. We're talking 70, 100, even more different stamped metal pieces. All of them have to be painstakingly welded together by a massive body shop of hundreds and hundreds of robots. Tesla's Giga Press, a machine the size of a small building, throws all that out. It casts the entire front or rear underbody as a single piece of aluminum. Just that one innovation, it eliminates over 300 robots. It erases 600+ welds. It frees up a massive amount of factory space. The resulting part is stronger. It's lighter. and it is critically, unbelievably faster and cheaper to make. That single Giga part, that is the Lego block that the unboxed method is built on, and this is the part that should make you hit that like button. While competitors are just now scrambling to order their first Giga presses, they're already years behind, because Tesla isn't just ahead in the machine, it has a multi-year lead in the metallurgy, the secret sauce, that special aluminum alloy that is strong, not brittle, and perfectly castable at high speed. That is a deep, costly moat, and for legacy automakers with their billion-dollar investments in those old-world body shops, crossing it might be impossible. So, you have the unboxed skeleton. Now, you need a nervous system. And for over 60 years, the entire auto industry has been locked into a dying standard, a 12-volt system. You have to understand, this 12-volt standard was designed for simple machines, a car with lights, a radio, and maybe power windows. But today, your car is a supercomputer on wheels, and that 12-volt system, it's become a critical bottleneck. The problem is just basic physics. You've heard the equation, power equals voltage times current. If you want more power, say for faster moving seats, a more powerful audio system, or the advanced steer-by-wire you see in the Cybertruck, you have to raise either the voltage or the current. And since the industry has been stuck at 12 volts, their only option was to drastically increase the current. The result? Thick, heavy, expensive copper wires to manage the heat and the load. We're talking about a wiring harness in a modern luxury car that can weigh over 50 kilograms. That's over 110 pounds. It's miles of copper. It's one of the most complex, costly, and manually installed parts in the entire vehicle. Worse, you hit a hard limit. You simply cannot run the high-power systems of the future on a 12-volt rail. Not efficiently, not safely.
So, what does Tesla do? They change the equation by moving to a 48-volt system, first in the Cybertruck and now standard on their next-gen platform. They flip the table. Think about it. To get the exact same amount of power, if you multiply the voltage by 4, you can divide the current by 4. That is a profound change. A 4 times reduction in current means you can use wires that are dramatically thinner, dramatically lighter, and dramatically cheaper. And the power you lose as heat? That drops by a factor of 16. The Cybertruck's wiring harness is a fraction of the size of a normal truck's. This saves money, this reduces weight, which increases range, and it massively simplifies that unboxed manufacturing process we just talked about. It's the key that unlocks the Ethernet data bus, where a single cable can finally carry both power and data, destroying the one-wire per function nightmare of the past. But this is the part that should have every legacy automaker terrified, and it's why you need to click that subscribe button for Dravexa. This shift to 48 volts, it's not just an internal change, it is a shockwave to the entire global supply chain. For decades, companies like Bosch, Continental, and Denso have perfected the 12-volt world. All those window motors, the pumps, the fans, they are all 12-volt. By moving to 48 volts, Tesla is effectively making its entire parts list obsolete. Suppliers now have to re-engineer, retool, and revalidate everything. A company like Ford or GM, they can't just switch. They are being held hostage by a supply chain that simply isn't ready. But Tesla? Because they designed so many of their own controllers, their own components, they can force the change. Their vertical integration lets them absorb the complexity. While their competitors, they're left tethered to a 60-year-old standard, adding yet another layer to Tesla's massive manufacturing and cost advantage. So, your factory is fast, your car's nervous system is efficient, but you still have a massive problem. Energy. The car still needs a breakthrough to be affordable for everyone. And that breakthrough is the 4680 battery cell. The name? It's just the dimensions. 46 millimeters wide, 80 millimeters tall. But its design? That is the revolution. You see, a traditional battery, like the 2170 cells in a Model 3, has two little tiny tabs at the ends. All the energy has to fight its way in and out through these two tiny bottlenecks. This creates a traffic jam. It creates massive heat, especially when you're charging fast or flooring it. The 4680's tabless design is pure genius. Instead of a tiny tab, it uses a shingled spiral. This means the entire edge of the battery's internal foil is the connection. The path for the energy is suddenly short, wide, and clear. This one change fundamentally rewrites the cell's properties. First, less heat, drastically less. Second, faster charging. With no heat to manage, you can flood the cell with power. And third, more power instantly. This is the secret to plaid-level acceleration. But that isn't even the real story. If you're enjoying this deep dive, hit that like button for Dravexa, because the manufacturing is the true change everything moment. It's a process called dry battery electrode, or DBE. For 50 years, everyone has made batteries the same way, a wet slurry. You mix the battery materials into a toxic wet paste, you paint it onto a foil, and then you run it through massive 100-meter-long energy-blasting ovens to dry it out. Tesla's DBE process, it stamps the active material dry directly onto the foil. No solvent, no water, no drying. Now, you need to understand how impossibly difficult this is. It is the holy grail of battery manufacturing. It's the main reason the 4680 ramp-up was so slow. The old wet method is like painting a wall. It's slow, but the paint spreads evenly. The dry method is like trying to spread a layer of fine dust perfectly evenly on a wall, make it stick, and do it at lightning speed. It's like trying to compress fine gravel into a perfect mirror. And as of 2025, Giga Texas is finally scaling it. This process, it doesn't just promise to cut factory footprint and energy use by 10 times. Internal reports are already clear. The 4680 cell is already cheaper for Tesla to make than anything they can buy from suppliers. This is the final piece of the puzzle. You combine this cheap, powerful cell with a structural pack where the battery is the floor of the car, saving 370 parts, and you have the key. This is the only way the $25,000 car is possible. It's the only way that Tesla Semi works.
So, the 4680 cell is the heart, but now we talk about the brain. Full self-driving. For years, FSD has been this promising, controversial, coming soon beta. But with version 12, it went through a change as fundamental as the jump from a flip phone to a smartphone. You see, the old way, FSD 11 and everything before it, was a mountain of code. It was a complex, human-written stack. Hundreds of thousands of lines of C++, a giant, fragile rule book. If the camera sees a red light, then apply the brake. If a car is merging, then calculate its trajectory. If it's a stop sign, but there's a pedestrian and the cross traffic is clear. This approach is brittle. It's impossible for a human to write a rule for every edge case the real world can throw at you. A stop sign hidden by a tree. A construction worker waving you through a red light. This is why true self-driving has been almost solved for a decade. So with FSD V12, Tesla did the unthinkable. They deleted it. They deleted over 300,000 lines of that C++ code, and they replaced it with a single end-to-end neural network. This new system was not programmed, it was trained. Tesla fed it millions of video clips of its best human drivers and essentially told the AI, "Watch this. Learn to drive like this." And it did. Now the system takes in raw video from the cameras,
and outputs steering, acceleration, and braking commands. Photons in, controls out. This is the ChatGPT moment for physical AI. The AI is predicting the next most likely driving action based on all the video it has ever seen. It learned how to creep at an unprotected left turn by observing humans do it, not by reading a rule. And this system is infinitely scalable. To make it smarter, you don't hire 1,000 engineers to write more if-then rules. You just curate new, tricky video scenarios, add them to the training set, and recompile the brain. But an AI is only as good as the data it's fed and the computer that feeds it. First, the data. With over 6 million FSD-capable cars on the road, Tesla has the largest data-gathering operation in history. When a driver takes over, the system flags that video clip, that difficult, snowy left turn, and uploads it to the data factory. Second, the computer. You've probably heard of Dojo, Tesla's custom supercomputer. But here's the Dravexa level update, because as of late 2025, the game has already changed. Tesla realized that having one giant separate computer for training, Dojo, and a different chip in the car for driving was inefficient. It was a bottleneck. So, they're pivoting. They are now focused on a unified AI architecture. New chips called AI5 and AI6 that will do both. They are building their new training supercomputer, what you could call Dojo 3, out of the same powerful chips that will be in their future cars. This creates the ultimate flywheel, a doom loop for competitors. Better AI leads to a better FSD. More people use it, more data is collected, the AI gets better, faster, and their new unified computer spins this flywheel at a speed and a cost no one else can match. This is the only path that plausibly solves full autonomy. And when it does, it unlocks the single most disruptive economic force of all, the robotaxi. A $25,000 car that can drive itself 24/7 and earn $30,000 a year. That isn't a car anymore. It's an asset, and it's one that will change our cities and our world forever. If you want to see that future happen, make sure you're subscribed to Dravexa. So why does the robotaxi still matter? Why is it a pillar of the next 5 years? Because for the first time, the pieces are no longer theoretical. FSD is improving faster because training compute exploded. Manufacturing is being redesigned from the ground up with the unboxed process to slash vehicle costs. And the rollout strategy itself has matured. Instead of trying to flip the world overnight, Tesla is aiming small, geo-fenced, carefully chosen cities like Austin. Prove safety in a constrained environment, earn regulatory trust, then expand. That's not hype, that's discipline. And if Tesla clears that final hurdle, true unsupervised autonomy without a human safety net, the impact is hard to overstate. Ride-hailing companies feel the ground shake. Car ownership in dense cities starts to look inefficient. Parking lots become prime real estate instead of dead space. Transportation shifts from a product you buy to a service you tap. For Tesla, it's a business model flip. Hardware margins give way to recurring revenue. Miles driven become income. The company stops selling cars and starts selling movement itself. But here's the truth that separates vision from reality. Everything depends on that last step, the hardest step, the one no one has solved yet. Safe, reliable, regulator-approved autonomy without a human safety net. That's the biggest if in Tesla's entire plan. And the next pillar? It's the one that quietly supports all of this, from cars to robots to cities, without ever touching a road. And now, the final pillar. The one that quietly connects everything.
Because what if your car wasn't just transportation? What if it was infrastructure? This is vehicle-to-grid, V2G, the moment the car stops being an energy taker and starts becoming an energy player. Here's the idea. Right now, your EV pulls power from the grid, one direction. Simple. V2G flips that arrow. Two-way charging. Your car can take energy when it's cheap and give it back when it's valuable. Power your house during a blackout. That's vehicle to home. Sell energy back to the grid during peak demand. That's vehicle to grid. For years, Tesla mostly ignored this. Powerwall handled home backup. Cars stayed cars. But then something changed. In 2023, Tesla confirmed it was reworking its power electronics to enable bidirectional charging directly in vehicles. That was the signal. Now, precision matters here. This was a goal, not a guarantee. As of late 2025, there is no global V2G rollout, no universal switch flipped. The Cybertruck and the new V4 superchargers appear to be the first pieces of hardware truly built for it. And scaling V2G is hard, painfully hard. You need compatible vehicles, chargers, software, standards, and, most difficult of all, utility companies willing to cooperate. Utilities move slowly, regulations move slower. But the payoff? Enormous. One EV battery can power a house for a day or two. Now, zoom out. Millions of Teslas sitting idle overnight. Garages, parking lots, streets. Together, they form something unprecedented, a massive distributed battery spread across entire countries, a virtual power plant. It absorbs excess solar and wind when supply is high, feeds energy back when demand spikes, smooths the grid instead of stressing it. Suddenly, renewables scale better, blackouts become rarer, and owning a Tesla starts to mean something very different. Over the next 5 years, this is how it begins. V2G-capable hardware becomes standard. Pilot programs roll out. Your car doesn't just cost money, it earns a little. Passive income from energy, built-in backup power for your home, resilience baked in. And for fleets, this gets even bigger. A future robo-taxi network doesn't just move people, it arbitrages energy, charging when power is cheap, selling when it's expensive, lower operating costs, higher margins. The grid and the fleet start working together. This is Tesla's quiet endgame in energy, not just putting cars on the grid, but using the fleet to actively manage it. And now, step back, because this is the full picture. 6 innovations, already moving, already compounding. The 4680 battery slashes cost and unlocks scale. New chemistries push range and longevity. The AI pivot builds the brain, faster, cheaper, smarter. AI 5 ties intelligence directly into the car. The robotaxi reimagines transportation itself, and V2G plugs the entire system into the world's energy backbone. These aren't separate bets, they're interlocking gears. Cheap batteries make robotaxis viable. Massive AI makes autonomy possible. Autonomy creates fleets. Fleets become energy assets. Energy assets feed the grid and the margins. That's the flywheel. Tesla's next 5 years aren't promises scribbled on a stage. The factories are real, the chips are real, the software is real, the hard work is happening now. The road ahead is brutal, manufacturing hell, regulatory walls, technical cliffs. But if this works, transportation changes, energy changes, cities change, and you're watching the blueprint execute in real time. If this deep dive reshaped how you see Tesla, take a second to like and subscribe to Dravexa, because this channel exists to connect the dots before they become obvious. Now, I want to hear from you. Which part of this future excites you most, And which part do you still doubt? Because history doesn't ask for permission, it just gets built.